So I want to just go over really quick two things that we learned from last time, the last notes. X squared times x to the third. Remember here when we have the same base, and here in this case the base is x, and it's x squared and we're multiplying times x to the third, remember we add those two. So it's going to be x to the fifth. When we have something raised to a power, remember we have to distribute this 2 to each piece inside. So it's going to be x to the third times 2, and then y squared times 2. So it's going to be x to the sixth, y to the fourth. Okay, so I just wanted to go over that before going over our new topic, because our new topic, instead of multiplying, this time we're going to be dividing. Okay, so let's take a look at dividing monomials. So to divide monomials, we're going to use the quotient rule. So look right here, this is saying x to the a, so x to some power, over x to another power, so x to the a over x to the b equals, we're going to subtract the powers this time. We're going to take the top one, a, and we're going to subtract it from the bottom. So our quotient rule says to take x to the a power and subtract the bottom, subtract b, subtract the exponent on the bottom. So if we look at this first one, we have x to the fifth over x cubed. So you notice how they're both x's, so we need the same base in order to subtract or divide. So it's going to be x to the 5 minus 3. So x to the 5 minus 3, well 5 minus 3 is 2, so it's x squared. So same thing here, notice we have the same base, we have a k, we're going to subtract that 2. We're going to say k to the 12 minus 2. And that's going to be k to the 10th. Look here, this time it's the same. So we're going to say m to the 3 minus 3, right? Well, 3 minus 3 is 0. So this is really important. Anything raised to the 0 power, anything raised to the 0 power equals 1. So it doesn't matter if it's m to the 0, if it's 100 to the 0 power, if it's negative a million to the 0 power, anything raised to the 0 power equals 1. So when we have m to the 0 power, it equals 1, and that makes sense because think about up here. Anything over itself equals 1. For example, if we had something like 2 over 2, doesn't that equal 1? If we had something like negative 11 over negative 11, doesn't that equal 1? So in the same way with the variables here, m cubed over m cubed equals 1. Okay? All right, let's look at this example down here. So now we're going to look at the a's and b's separately. So let's look at our a's. We have a 6 over a squared. So it's going to be a to the 6 minus 2 times b to the 4 minus 3. So we're going to change it from division to multiplication here because we're just collecting like terms pretty much. It's almost like collecting these powers together. So 6 minus 2 and then 4 minus 3. So this is a to the 4th times b, and that's your answer. So look here. I want you to try number 5 and 6. I forgot that I asked you guys to do that. So try number 5 and 6. So if we have examples with coefficients, remember a coefficient is the number in front of the variable. Then the first thing we're going to do is divide the coefficients, and then we're going to simplify. So let's take a look at number 7. Number 7 says 6 to the x to the 4th over 2x cubed. The first thing we're going to do is divide 6 and 2. So 6 divided by 2 is 3. And then we're going to take a look at these two variables, x to the 4th over x cubed. Whenever we're dividing monomials, remember we subtract. It's going to be x to the 4 minus 3. So it's 3x because 4 minus 3 is 1, right? Okay, so let's look at the next one. Look at 14 divided by 7. 14 divided by 7 is 2. Then we're going to look at the r's. So r squared over r, remember we just subtract, so it's 2 minus 1. And then we're going to look at the s's, so s to the 2 minus 1. So it's 2rs. All All right, you guys try number 9. Number 10, so number 10, again, we're going to divide. So negative 15 divided by negative 3 is 5. Then we're going to look at the x's, 6 minus 5, we're going to subtract. We're going to subtract 5 minus 3 for the y's, and then we just have our z by itself. There's no z on the denominator, so we're just going to leave it z. So 6 minus 5 is just x, it's just 1, right? X to the 1 is just x. Y squared, z, and that's our answer. So try 11 and 12. Let's go down to 13. So it says simplify each expression completely. Look at the difference here. We need to distribute this 2 by using the power rule. So we're going to go back, just like how I explained at the beginning of this, these notes. We're going to go back to thinking about what we did last notes, the last guided notes we did. We distributed this 2 in, right? So we're going to do that. And we know that the 3, that 3 right there is 3 squared, x to the 5 times 2. So that's just from last time's notes. And then over 27, x cubed. So we leave the bottom, the denominator, we're going to leave that the same. And we're just distributing this 2 in. 3 squared, x to the 5 times 2. Well, 3 squared is 9, x to the 10th, over, and we're just going to keep that 27x cubed. So let's look at the numbers now, because now we're gonna divide this, right? So the first step here is we always want to take care of the numerator. We want to simplify the numerator or the denominator first. We can't do anything on the denominator, 27x cubed just stays the same, but we can simplify the top first, and now we're going to take a look at the whole fraction. So we're going to look at 9 over 27. We can divide the top and bottom by 9, right? 9 divided by 9 is 1, and 27 divided by 9 is 3. So notice instead of 9 over 27 is not equal 3, it equals 1 over 3, equals 1/3. It says 9 divided by 9 is 1, and 27 divided by 9 is 3. So we just took care of the numbers. Now we're going to look at the letters. We're going to look at the x's. So it's going to be x to the 10 minus 3. So that's 1 x to the 7th over 3, or x to the 7th over 3. Remember that 1 is just, it's not necessary. We don't need it. Or we can make it 1/3 x to the 7th. All 3 of these are equal. So I really want you guys to look at this and notice these are all 3 the same thing. If I wrote any one of these 3, you should be able, or any one of these, you should be able to write it like the other 2. Okay, let's look at 14. So 14, we're distributing that 3 again. So it's 2 cubed, a to the 2 times 3, b to the 4 times 3. We're going to keep that denominator the same because we don't need to do any work on the bottom. We just leave it the same. So remember, 2 cubed is not 2 times 3, it's 2 times 2 times 2. 2 times 2 times 2 is 8, a to the 6, b 12th, and we're going to keep the bottom the same. So now let's divide. Well, 8 over 4 this time, we can divide 8 and 4. We can divide both of those by 4. 8 divided by 4 is 2, and 4 divided by 4 is 1. Now we're going to look at the variables. A to the 6 over a cubed. Remember, we subtract up, so it's going to be 6 minus 3. Let's look at the b's. B to the 12th minus 7. And we can simplify. We don't need this 1 on the denominator, right? That 1, it doesn't, anything, we can put anything over 1, but we don't need it in our final answer. So it's going to be 2a to the 3rd, b to the 5th, and that's our final answer. So I want you to try 15 and 16. And then let's take a look at 17. So look at the difference between 17 and the other ones that we just did. When the whole fraction is raised to the same exponent, we're going to simplify it first. What does that mean? That all I'm saying here is we have to simplify what's inside of the parentheses before we can look at this guy, because it's going to make it a whole lot easier if we simplify this first. Do you see how 2 over 4, m to the 4th over m squared, n squared over n? We could simplify in here first before looking up here. And that's important because it's just going to make everything a lot easier. So let's do that first. Let's look at 2 over 4. 2 over 4 we can write as 1/2. If we divide 2 divided by 2 is 1, 4 divided by 2 is 2, so 2 over 4 is the same thing as 1/2. Let's simplify the m's now. M to the 4 minus 2, and the n's, n to the 2 minus 1. So all we're doing here is we're subtracting up. 4 minus 2, 2 minus 1, because there's an invisible 1 here. We're going to wrap that whole thing up and put it to the third power, because this whole thing is wrapped up here and put to the third power. Now we're going to simplify these guys. So it's going to be 1m squared, because 4 minus 2 is 2, n over 2. And we're going to raise that to the third power still. So notice now we're going to look at the third power. See how I just brought that down every single time? I simplified what's inside first. I can't simplify this anymore. So now I'm going to distribute that 3. But I have to distribute the 3 also to the denominator. I have to distribute it to every single piece of what's inside this parenthesis. So I see how I distribute it to the 1. I distribute it to the m squared. I distribute it to the n. But I also distributed it to this 2. So look at the bottom when we get there. So it's going to be 1 cubed, m to the 2 times 3, n cubed, over 2 cubed. So this is really important. A lot of people forget to give this 3 to the 2 down here, but you need to remember that piece. What's 1 times 1 times 1? Some people were saying that this is 3. This is not 3. Be careful here. 1 times 1 times 1 is just 1. So m to the 6th, n cubed, all over 2 times 2 times 2 is 8. That's your final answer. Okay, so let's look at 18. Remember, simplify what's in. So look at these directions. Simplify, simplify first. So we can simplify 12 over 15. We can divide both of those by 3. So 12 divided by 3 is 4. 15 divided by 3 is 5. Now let's look at the k's. So we have k, well, we have a 5 on top and we have a 1 on bottom. So 5 minus 1. And then we're going to, don't forget to wrap it in parentheses and square it, right? We're not going to touch this squared until we're finished simplifying on the inside. So 5 minus 1 is 4. So it's 4 k to the 4th over 5, squared. Now we're going to look at this guy. We're going to give it to each piece. So to that 5 on the bottom as well. So we have 4 squared, k to the 4 times 2, over 5 squared. Remember that this is 4 times 4, which is 16, and this is 5 times 5, which is 25. So 16k squared over 25, and that's your answer. Okay, so try 19. Let's look at 20. So 20 says, so look at, okay, I remember on the last page I said we need to simplify the top first or the bottom first before we can look at the whole fraction. So do you see how we can actually multiply these out? So we have to do that first. So like 9 times 4, that's 36. X to the 5th times x is x to the 6th. And y to the 6th times y, 6 times, and then that 1 right there, remember we add those, 6 plus 1 is y to the 7th. Now we just keep the bottom the same. This didn't change. There's nothing we can do to simplify that. But now we can actually simplify this fraction and start subtracting exponents here. And 36 divided by 6 there is 6. X to the 6 over x squared is usually 6 minus 2. Y to the 7th over y to the 4th is 7 minus 4. So it's 6 x to the 4th y cubed. And that's your answer. Okay, so I want you to try 21 and 22. We are almost finished. I'm not going to have you guys try 27, 28. So we just have a couple more. So let's look here. We distribute. So remember I said we need to solve the top or bottom first. So in this case, we don't have anything to solve on the bottom, but we have to distribute this 2 first and this 3 before we can do anything else. So it's 2 squared, x to the 3 times 2, 3. Oh, I did that wrong. It's not 3 squared, huh? It's 3 to the 3rd. Okay, so let me fix that. So this piece is 3 to the 3rd. Y to the 4 times 3. And look, I just kept this here, just moved it over. There's nothing we can do there. Okay, so 2 squared is 4, x to the 6th. Now 3 to the 3rd is not 9. it is 27. I did that wrong when I was doing it initially. So 27 y to the 12th over 12x to the 4th y to the 5th. Okay, so now we're going to multiply those numbers. We're going to multiply 4 times 27. So 4 times 27 is not 36. It is 108. So 108 x to the 6th y to the 12th over 12 x to the 4th y to the 5th. Okay, so now we're going to take a look. 108 divided by 12 is 9. And then x to the 6th over x to the 4th is 6 minus 4. Y to the 12th over y to the 5th is 12 minus 5. So it's 9 x to the x squared, y to the 7th. And that's your final answer there. Okay, I want you to try 24. Let's do 25. Then I'm going to have you guys do 26, and we're going to skip 27 and 28. So this is the last one we're going to do together. So again, we need to multiply the top first. So we need to multiply 8 times negative 3, which is negative 24. We're going to collect those c terms. So c times c to the 4th. Well, that's just c to the first power, right? So 1 plus 4 is 5. And then we don't have any d's over here, so we're just going to keep it d to the 3rd. And we're going to keep the denominator the same. There's nothing we can do here. It's going to stay 6c squared d. And we're just going to keep this, we're just going to kind of keep bringing this down because we can't do anything here yet. So this guy's just going to hang on the end for a while. Now we're going to be able to divide. So 24 divided by 6, negative 24 divided by 6 is negative 4. Then we can look at the c's. So it's c cubed, d squared. Minus, we're going to bring this down, 9c to the 3rd d squared. Remember when we're subtracting or adding, and we have all this crazy stuff like c cubed d squared, if they match, c cubed d squared, c cubed d squared, if these exponents match, we can combine like terms. So I can combine negative 4 minus 9, which is negative 13. Because those match, I can do that. And I just keep this the same. So remember when we're multiplying, it's different. If these two are multiplying together, we would add these. But because we're negative 4 minus 9, we're not multiplying. We're subtracting. So negative 4 minus 9 is negative 13. We're going to keep these the same. So why don't you try number 26, and we're not going to do 27 and 28. Raise your hand when you're finished.